We are now equipped to study the basic aspects about an expanding universe. To recall, these were the two equations which we had. This equation was obtained by adding the potential energy and the kinetic energy of a test particle and equating it to zero, because from observations we know that the role played by the total energy of the system happens to be zero. The second equation we got by studying the forces that are acting on this test particle. A is a typical distance between any two points in the universe, and clearly, since the universe is homogeneous, what should matter is the relative values of A at two different times and not its absolute value. Hence, this A will not be determined up to a multiplicative constant. This pressure P is the pressure exerted because of the random motion of the particles of the fluid which inhabit the universe. And as I mentioned, P appears here because if the particles are moving with speeds which cannot be neglected as compared to the speed of light, then because of the motion it will contribute its own energy in addition to the rest mass energy, and that will add up as a cause for gravity. Now, if you take any distance, I can construct a volume from the distance by taking a cube. So a cube here, just like A here is a measure of distance between 2 points, A cube is a measure of the volume in space. Rho is the density of matter, and rho into A cube is hence the mass of matter inside this cube. I have taken here the speed of light to be 1, which means that all velocities I will measure as fractions of speed of light. And so this rho A cube is not only a measure of mass in this volume, it is also a measure of total energy in this volume. So as the universe expands, d rho A cube is the change in energy from one time to another. Once again, since A cube is a measure of volume, dA cube is a measure of change in volume during this corresponding time, and P into dV is nothing else but the work done. So this left hand side is nothing else but the familiar left hand side of the first law of thermodynamics, that is dE plus P dV. And we know from first law of thermodynamics that this quantity will be 0. This is nothing else but a reflection of the fact that total energy is conserved. So in this simple-minded approach, it will be enough for us to know this much about this equation, that this is like the conservation of energy. However, the story doesn't end here. We need to have this precise relationship between P and rho. So these equations are to be supplemented by what we call the equation of state, which tells what is this relation. For simple cases, we have P equal to W rho, where W is a constant. For radiation, it is 1/3. For pressureless matter, it is 0. In general, P can be any function of rho. There are some restrictions, like you should not have the speed of sound exceeding the speed of light. But for those restrictions, this can be any function, and this is one simple form of that. And using this relationship between P and rho, we can derive further results from this equation. Now for pressureless matter, we have A dot square by A square equal to 8 pi G by 3 times rho. And for pressureless matter, if I substitute W equal to 0, in my previous equation, which was a reflection of the first law of thermodynamics, we will get rho, the energy density, going as 1 by a cube. With these two equations, I can solve it and immediately get A goes as T to the power 2 by 3. So from this simple-minded approach, we have got for a pressureless matter how the size of the universe increases with time. It goes as T to the power 2 by 3. Similarly, if I consider the case of radiation, then W is 1 by 3. I use this in the continuity equation, that is the equation representing the first law of thermodynamics, and I will get the density going as 1 by a power 4. And I use this in this equation again, and I get A goes as T power half. So I see that depending on my equation of state parameter, the evolution of the universe is different. Here there is an interesting observation. If I subtract this equation from this equation, I arrive at this, and I get A double dot by A equal to minus 4 pi g times rho by 3 plus P. Now, if the pressure is greater than minus rho by 3, then we find that this portion is greater than 0 and the right hand side is less than 0. In other words, the universe decelerates as it expands. This is the scenario for most normal kinds of matter in the universe. However, of late, one feels that one can have another matter in the universe where this inequality doesn't hold and makes the right hand side positive, and this will make the universe accelerate as it expands. How many minutes?